Alright, so let's have a look at what an ester is, and also how we name it, and yeah, the properties thereof. So basically, the general formula of an ester is that we have this R group, which is an alkyl group, COO, and another alkyl group. Now, if we look at it as a structural formula, it's an alkyl group. This here starts to look a bit like a carboxylic acid, but then when the extra H is on the carboxylic acid, we've got another alkyl group. And we can also draw it as a structural formula like this, or like this. And you'll see this is the same. So the alkyl group here, carboxylic acid, almost alkyl group. Where here it's alkyl group, carboxylic acid, almost alkyl group. So these R's are alkyl groups, and we have the little one up there. Actually, it's an apostrophe. The little apostrophe there to distinguish between the two. The functional group is this in the middle here. This C double bond to the O, and then another oxygen off there. And basically, it's the result of an alkanoic acid, which is the R group. Okay, that's why it looks like an alkanoic acid, combining or condensing with an alkanol, which is the R apostrophe. And it's important you get those right. So it's an alkanoic acid, that's that, plus the R group, which is this section here. So what we get is you've got your alkanoic acid plus alkanol. And see how we've drawn the alkanol backwards to what you would normally. Normally you would see an alkanol drawn like that. And the hydroxyl at the end of the alkanoic acid and the H off the hydroxyl group on the alkanol condense out, so it's a condensation reaction to form water plus an ester, that's the ester right there. But it's really important that you notice where that oxygen comes from. So that oxygen is from the alkanoic acid. This oxygen is from the alkyl group, the alkanol. So how do we name them? Basically, the first part of the name comes from the alkanol, which is this side. You name it as an alkyl group, and it's single bonded to an oxygen just here. Okay, so that would be ethyl. Okay, now the second part comes from the alkanoic acid. That's this section. Okay, and you change the suffix from oic acid, so that would be propanoic acid. You change it from propanoic acid to propanoate. Okay, so it's ethyl on this side, propanoate. That means this chemical is called ethyl propanoate. So you look for which carbon is only bonded to an oxygen on its own. Okay, and you treat that as an alkyl group. And you look for which carbon is bonded to double bonded to an oxygen and a single bond to another oxygen, and that's your anoate. So ethylanoate, so propanoate. And that's how you name them. So let's have a look at the trends of the properties. So it's propyl ethanoate. Let's have a look. Okay, so short chain esters are volatile liquids. Okay, propyl ethanoate is a short chain ester, and its melting point is minus 95 degrees Celsius. So as the chain length increases, the liquids become less volatile, and they become more oily and viscous, and eventually they become soft solids or waxes. And so beeswax here is quite a long one. It's C15, H31, COO, C30, H61, and it's got a melting point of 60 degrees, or 60.5. And that's quite a long chain there, so that's that one as we go along. Alright, so let's have a look at the uses of esters. And they're a naturally occurring chemical. Beeswax is a naturally occurring chemical. But we see them as flavoring or scent agents. Remember, they're volatile liquids quite often, if they're small enough, in plants and fruits. Animal fats and plant oils also tend to be esters. The production of them, however, involves extraction. So when we want to use them, we've got to extract them from a natural source, or you manufacture it in an industrial environment. And this is actually usually far less expensive just to build your own. So what do we use them for? We use them to flavor and scent food. There are some esters we use as solvents and thinners. We use it for medications, and we also use it for plasticizers. So it's a really useful class of chemicals. So let's have a look at one in particular, octal ethanol. So this would have been an 8-chain, so this would be octanol, which is combined with ethanoic acid, and it goes from octanol to octal ethanol. So octal ethanol is associated with the orange flavor. Like that's when you taste an orange, this is what you're tasting. And it's the main ester that's present in oranges. It's produced basically by reacting a mixture of 1 octanol with ethanoic acid, and you use sulfuric acid as a catalyst. It's a dehydrating agent, so it helps pull that water out of the condensation reaction. So here we have, here's our octanol, and we combine it with ethanoic acid over heat, that's what that means, with concentrated sulfuric acid. And it gives us octal ethanoate plus water, because it's a condensation reaction. So once produced, the octal ethanoate is used as a flavoring agent in foods, like Jaffas, for example, so any orange-flavored confectionery. So I hope that made sense. There's a lot to take in there. If you have any questions, put it in the comments below, and we'll get back to you as quickly as we can. Thanks for watching. Bye now.